Work it, make it, do it, makes us.
Hello. Welcome. Dear Lord, that's a lot of you. Cool. All right. So today we will be talking about test driving and testing modern web applications and how we can do this at scale. So can you just do me a quick favor? Can everyone who can hear me raise their hand? Awesome. So now I know two things about you. First of all, you can hear me. Secondly, I can ask you questions. It's perfect. All right. So, automation. As we know, robots are slowly taking over. They've even taken over DevOps and DevOps conference. So now, may I ask you the first question? How many of you have unit or integration tests on your projects? All right. Well, that's pretty much everyone. Brilliant. And how many of you have so-called end-to-end tests? All right, so keep your hands up. Keep your hands up if you're perfectly happy with how quickly those tests run, how good feedback they give you, and how easily you can act on this feedback. Awesome, we've got one person left. Lovely. So it turns out that we're automating pretty much every single aspect of our software delivery process. So we've automated the deployments, we've automated the infrastructure provisioning. But one thing that we actually are pretty bad at is testing. So the good news is that, well, you're not alone. The bad news is that we're all in this together and that we're actually a majority. But firstly, please allow me to introduce myself. So my name is Jan Molak. I'm a continuous delivery consultant. What this basically means is that I work with companies and teams around the world, and I help them enable the continuous delivery of their projects. What this usually means is that, well, it's not only about scripting Jenkins, as many of us might think. It's actually about addressing every single aspect of the software delivery process that makes your software testable and deployable in the first place, which usually covers TDD, BDD, and other practices in this space. So as part of my work, I also write some open source projects. So some of you might probably associate me with your build monitors being read, perhaps. Or maybe my recent project, the Serenity acceptance testing library. So I would like to tell you a little bit more about this library today as well. So let's start with talking a little bit about the problem with testing and how we approach it on agile projects. I'm guessing that now we all work on some sort of an agile team, I suppose. All right. Well, no one's going to admit that they work on a waterfall team now, right? Okay. So it turns out that the recent research from Capgemini brought to light some interesting findings. So despite the continued adoption of agile methodologies, challenges with quality and testing in agile projects are increasing. That's an interesting finding. Why is that, right? We do TDD, then why is that happening? Now, another report from Gartner, what they found is that, well, testing cannot keep pace with demand for faster delivery. And why is that? Well, due to heavy reliance on manual testing and inability to scale the technology and process. Okay, so what testing do they actually talk about? So what I would like to talk about today is the acceptance testing aspect of our software delivery. Are you guys familiar with acceptance testing as a concept, as a process, and so on? So basically, the reason why we do acceptance testing is that we want to make sure that the software we deliver actually meets the requirements, so we deliver the right thing. So while TDD is brilliant when it comes to building the thing right, the acceptance testing is actually what helps us build a thing that addresses the real business problem. And this is often neglected. So to look at this problem in a bit more detail, let's look at how this typically works on an agile team. So I guess we all have some product owners, some developers, some testers on our teams. Is that a fair assessment? So as a product owner, what I mean by product owner is someone in a business function on a team. So a business analyst, a product owner, and so on. So now the way this typically works is that the product owner comes up with a bunch of requirements to address a business need. Those are typically phrased as user stories. Now, all those user stories, in order to follow the invest principle, especially the T, so being testable, they need to have some sort of acceptance criteria on them. So, can you please raise your hand if you actually have acceptance criteria on your stories? All right, that's great, that's most of us. And are they any more specific than it should work, or it should have tests? Okay, about 7, 8 people, nice. So that's the first issue. So right, what typically happens next is that the user story with fairly vague acceptance criteria get to the development sprint. So a developer works on those stories. They build some web app, some system. They also write some unit and integration tests to make sure that whatever they've implemented is correct or is as good. It works the way they wanted it to work. And then the whole thing lands on the tester's desk, where the tester typically writes the automated acceptance tests to make sure that whatever the developer built actually meets the criteria. Well, they also need to somehow report their findings to the product owner. This usually works either via the release readiness reports in large organizations or just an email in smaller companies. And they also raise a bunch of bug reports as well. Now, in theory, this whole process should happen within one sprint. Okay, so does this resemble what you guys typically face on your projects? Okay. Does this whole process ever happen within one sprint? Okay. So we've got like 2 nods in the audience. 3, sorry. All right, so what often happens is that the implemented application lands on tester's desk around 45 minutes before the end of the sprint, and that's when they start their work. So the poor guys are trying to figure out and somehow reconcile whatever they got with whatever was required, write some automated tests using Selenium, WebDriver, whatever, and then send the bug reports saying that everything's broken, just don't do it again. And this thing typically happens in a separate sprint, like a testing sprint. Do you guys have testing sprints on your teams? Okay. So now, the trouble here is that if we test our software after the software is already built, if the bulk of the testing happens once the software is built, it usually takes time, right? So first of all, we need the software to be present in the first place. So we can't really test drive the software with this sort of acceptance tests. So the reason why this whole process tends to be slow and why we tend to have those acceptance testing sprints, etc., in my opinion, is caused by several misconceptions. So first of all, acceptance tests have to be end-to-end. So many teams conflate the concept of an acceptance test, a UI test, or a customer-facing test, and they all think that it's all the same thing, while those are actually orthogonal characteristics. So if you think about it, the end-to-end tests requires the system to be built in the first place. So me and my colleagues like to use the calculator example. So if you imagine the old school calculator, right, it will have some sort of business logic implementation somewhere inside it. It will have a user interface in the form of a keypad and so on. If we now try to test every single mathematical operation using the user interface on a system that's already built, well, it's going to take some time, and the problems that we find will be, the description of those problems will be a little bit broad. So let's say we can't add on this calculator, but what part of the calculator is broken? And this problem is caused by the second misconception, that the acceptance tests have to run through the GUI, because that's what a user would do. Have you ever heard this statement before? Okay. So here's an interesting fact. The GUI is not the only interface of your system. So let me introduce you to the journey planner example that I would like us to focus on today. So a journey planner is an online system, I guess you probably have used before as well, that helps commuters optimize the route from one point to another. So let's say that we have a user story like that. So finding the fastest route, right? So as a commuter, I'd like to know the fastest route between two stations so that I get to my destination as quickly as possible. It's a fairly common user story. Now let's look at the implementation of such a story. And just a quick disclaimer, I'm not affiliated with the Transport for London. I just happen to be using it every day. So this journey planner could have some sort of a web UI, right? So to implement this story, we would need to implement some sort of business logic on the server side, I suppose. We would need to build some user interface to present this website to a user. But there are also other users of our system. There could be third parties who want to integrate with our service through a REST API, for instance. We might have mobile apps that provide the same functionality to the user. Well, obviously, this sort of journey planner should probably also allow people to buy tickets. Well, this means that our app now got some enterprise integration. And what about the notifications, right? So that's yet another interface of our system. And we had a couple of talks about Siri and Alexa. So is Natural UI another interface to our system? So now, if we actually wanted to exercise our system as a user would, and run through every single scenario, through every single interface, what would we end up with? Quite large test suite, right? And that's another finding from that Gartner report, that now while we actually want to deliver faster and more complex applications, the test matrix grows many times faster because the number of delivery channels grow as well. But now we already know one thing, that coupling our acceptance tests to the implementation of a specific interface and running them against a fully assembled system makes them slow and fragile quite often. So if we actually try to write those tests when the system is built and during the development sprint, if we try to exercise the system through every single UI, through every single edge case and so on, we'll end up with a test suite that takes a long time. And I've actually heard of situations where a software delivery process was set up in a way that you had a development sprint, then the test automation sprint, and then a manual testing sprint, where the manual testers would just rerun the automated tests until they finally pass, and then yet another UAT sprint, and so on. So what this means is that a developer would only learn about a bug in their code a couple of weeks after they've already committed the code to the repository. And, well, first of all, this affects the feedback, right? I mean, if someone tells me about a bug I committed 4 weeks ago, I'll have to, again, dig through the code, figure out what I was supposed to do, how I wrote it, and so on. And the whole analysis process will take a long time. Now, this affects the delivery speed as well, because you don't know if the system is working until you actually go through all those testing sprints. So now, what could be a solution to this problem? I guess many of you have seen this picture before. If you have, please raise your hand. Let's see if that works again. All right, so it's about half of you. So years ago, Mike Kohn, in his book Succeeding with Agile, proposed a concept he called the test pyramid. So what he basically said is, now, in essence, is that on any software project that uses test automation, the majority of your tests should be the unit tests. You should have some service tests, and the UI tests should only form the minority of the whole testing group. Now, while the concept is sound in principle, there's a couple of troubles here. So, first of all, unit tests and UI tests, they serve different purpose. They serve different audience. Right? So another thing is that this test pyramid has been then copied by a number of different people, different authors, and they've now added some more layers to it. They even came up with some percentages, so you can actually run some stats on your code and find out your unit test should be 70%, and maybe your service test should be 20%, and the UI test should be 10. And then we had loads of conversations. So should actually be 20, maybe should be 25. No, if we have 26, is it fine? But the whole conversation is missing the point. So, in my view, instead of focusing on the test pyramid and focusing on this quantitative metric of how many tests we should actually have in our code base, perhaps we should think about what purpose they serve, what they do, what do we need them for. Are we just following the cargo call that when we write all those UI tests, do we actually need them? Are they useful? So the way I like to think about it is presented here at this automated testing quadrant. There's loads of models, and as we all know, all models are wrong, but some of them might be useful. So hopefully this one will be. So the way I like to think about it is that the automated tests have two types of audience in general. They are either useful for the development team, or they're useful for the business. Now, please note that I'm not calling those tests developer tests or business tests, because this causes another problem. If we call some tests business tests, we might come to a conclusion that it's the business who should write them. And on many teams, I've actually seen situations where developers just went to their business analysts and said, well, just write all those tests in Gherkin and just tell us when it's ready. That makes no sense, right? So Cucumber and Gherkin are collaboration tools, and we're not supposed to force business people to write those tests for us. I mean, it's our job as developers. But those business tests, the tests for the business audience, have a very interesting purpose. So first of all, they tell them if the project actually does what it's supposed to do. And if we have those tests, if the quality of feedback is right and they get this feedback promptly, then one thing we can avoid is status updates meetings and loads of reports being sent back and forward. You can probably tell that I'm doing a lot of work for the banks, right? But the trouble with the acceptance tests that run through the UI is that they're slow and expensive. They're expensive to write, they're expensive to maintain, and the feedback they give us is fairly broad, so we don't know precisely where the failure is, should they fail. So in our journey planner example, if we didn't find the right connection between two stations, is it the problem with the UI? Is it the problem with the service layer? Is it the problem with the domain logic? Did the test time out? Or did we just miss the element that's on screen? So we'll know that something's wrong, but we won't know exactly what that is. In terms of the unit tests, on the other hand, we've got fast feedback, so that's great. They're cheap to write, they're cheap to maintain most of the time. And when they fail, we know precisely what happened. So we've got a bug in this particular class on this particular line. And that's useful. The trouble with those tests, though, is that they won't tell you that this bug on this line in this class affects this particular business feature. So the feedback from unit tests is completely useless to the business. And we can try to tell the business that, we've got 95% code coverage. So, yeah, awesome. Does this feature work? Well, it doesn't. Okay, then what is your code coverage good for? And that's quite a common conversation. So over the last couple of years, I was trying to figure out how we can actually move those acceptance tests a little bit further down from the slow and expensive part of the quadrant to the fast and cheap one, so that they actually give the business the feedback they need, and then they don't take hours or days to run. Which brings us to part 2, bridging the domain gap. Now, what do I mean by that? So let's look again at this user story we talked about in the beginning. So finding the fastest route to a destination. So from the business point of view, when they give us a sort of story, they just assume that it's going to work the same via any delivery channel that our application has, right? I mean, it's just the same functionality, so why should it take longer? Why should it be more difficult to implement through those different channels? So now, what we typically do as developers when creating those sort of features, we extract the common functionality, right? We share it as packages between those projects. We try to reuse as much as we can. But what about the tests? Can you raise your hand if you have separate tests for separate delivery channels? So separate tests for the UI, separate tests for the REST APIs, separate tests for the mobile apps. I like the kind of. All right. So now the trouble is that now very often in the situation I told you about before, when the tester gets to write the test at the very last minute, they just try to script as quickly as they can and automate as quickly as they can using whatever delivery channel is ready at that particular point in time. What this usually means is that those scripts will be full of direct WebDriver calls or rest assured calls, etc. And all those tests will be expressed using the vocabulary from the implementation domain. So our test will talk about entering values into fields, clicking buttons, selecting values from drop-downs. They'll talk about sending JSON to a specific endpoint, response statuses, and so on. They'll talk about tabs. They talk about swipes. One thing they won't talk about is the actual business functionality that they're testing. So very often we find ourselves in a situation where even when the tests fail, we don't know exactly what features are affected. So then the tester has to go through those test results, figure out what's affected, and this analysis, again, it takes time. So they need to then summarize it somehow, and then again, it takes time, and then they send those summary reports to the business developers. But again, this usually takes hours, if not days. So in my view, this problem is caused by a domain gap. So what we're trying to do is we're trying to jump straight from a user story to an implementation of the test. Okay, let's look what we could do about this in practice. Does any one of you work with BDD, with behavior-driven development? Okay. Okay. I really like how the guy who has the fastest test is the guy who works with BDD. That's brilliant. We have it all. So in BDD, we often write our, well, so to speak, acceptance criteria for a user story in a form of scenarios. So they're not really acceptance criteria. What they are examples. They're examples to demonstrate certain business rules that the user story should enable. So in this case, we can have a scenario where Connie looks for the next train. So if she wants to leave Canary Wharf at 5 o'clock, then she should be told about the train at 5:01. Now, there's a couple of interesting things about using examples expressed in this form as part of our delivery process. So first of all, there's another misconception that Cucumber is a testing tool. It isn't. It's a collaboration tool that helps us build this so-called ubiquitous language that we know from the domain-driven design domain. So what we can do as part of coming up with those examples together, as developers, testers, and business analysts or product owners, is we can actually build common understanding of what is that we're trying to achieve. So for example, here, we have a person, Connie, who wants to find a train. And when we write this scenario down, we can actually ask ourselves a question. Well, okay, so she wants to get from Canary Wharf to Waterloo at 5 o'clock, and she should be told about the train at 5:01. So first of all, do we only have one line in Canary Wharf? Well, no, trains go in two directions, right? So we can update our understanding that we've got trains going in two directions. Secondly, if it's already 5 o'clock, should she be actually told about the train at 5:01? Does it make sense? Will it give her enough time to buy the ticket, to find the train, and so on? Well, that makes no sense whatsoever, right? So perhaps should be told about some more trains, maybe 503, 509, etc. So even at the stage of having this conversation, we already managed to build a better understanding of what is that is needed. Now, if we just jump straight away to implementing the feature, well, give me the next train, we will build a product that's completely useless to the customer. But now's the next question. How do we actually go about automating this scenario? Because we know that one of the things that Cucumber gives us is that we can turn those specifications into executable specifications, into executable examples. So what often happens here is we try to, again, jump the domain gap. We try to script those steps to interact directly with a specific delivery channel. So we'll see a step like wants to travel from Canary Wharf to Waterloo, open the website, enter the value into a field, click on a button, swipe, and so on. So what we do, typically do is we again couple our scenario to a specific delivery channel, and we end up in exactly the same situation as we just had before. So although using Cucumber here helps us a bit, we can still mess it up. So what do we do when we have a complex problem in software engineering? I mean, as we all know, any problem in software engineering can be solved by introducing a new layer of abstraction. Of course, except for the problem of too many layers of abstraction. But let's talk a little bit about what we could introduce between our scenario and our delivery channel, the external interface of our system. Now, to go here, I would like to tell you a little bit more about scenario decomposition. So the technique I would like to demonstrate is based on a user-centered design technique that's called hierarchical task analysis. And it's a technique that's been developed in the late 60s, imagine that, to train people in complex processes in the petroleum and pharmaceutical industries. But we can use it as part of our BDD process as well. And we can use it to build this better abstraction on top of our external interface of the system. So how do we do it? You probably remember this one step from the scenario I just showed you before. So Connie wants to travel from Canary Wharf to Waterloo at 5 o'clock. Now, one thing to note here is that I'm not using the phrase when I want to travel from one station to another. I've actually introduced a persona here, Connie. There are several reasons for that. Well, first of all, this allows us to be a little bit more empathetic about the customer. So research has found that when we start using personas in our scenarios, we actually associate ourselves better with the customers. We understand how they use the system a little bit better. Because otherwise, if we express everything from our point of view, well, then we make a certain number of assumptions straight away. So first of all, well, we are there sitting in a nice warm office. We're using a large screen monitor. We've got a fast computer and so on. If we start using personas such as Connie, and Connie could be a businesswoman on the go, she could be using our system on a mobile device over a crappy connection. So this helps us to think a little bit more from our customer's perspective. Okay, so let's take Connie. So in this technique, we first need to have an actor. So in our case, that's Connie. Connie has a certain goal. She wants to plan a journey. Now, in order to plan her journey, she'll need to perform a number of tasks. So she'll need to go to our journey planner. She'll need to choose the origin. She'll need to choose the destination, choose the time of departure, and confirm her selection. Now, you'll see that tasks such as choose origin or choose destination, they're not tied to any specific implementation, right? She could do this as well on her mobile device, or she could even do this through the REST APIs if we're using Hatos and so on. It's basically a business flow that we're expressing here. Now, each of those tasks could be further broken down into other tasks and specific interactions with the system. So, for instance, to choose an origin, it means to enter the Canary Wharf into the origin field, pick the first suggestion. To pick the first suggestion means to press the arrow down, press enter, etc. Now, an interesting thing about this approach is it's not just a sticky notes game, because each of those tasks could be as well represented in code. So if we have a goal to plan a journey, we can have a class, an object that actually performs this specific set of tasks. We could use the language that we captured in the scenario. We could represent it in our code. And we can do the exact same thing with every single one of those tasks. So if I want to say choose origin, well, then I can have a class and choose origin of Canary Wharf, and this will give me the task that actually performs this task. What this allows me to do is to create a number of small building blocks that can be then reused very easily. It's a small library that we can then share as code across teams, across projects. So if I have a team that, say, develops a little widget on the website, they could just create a bunch of tasks to interact with this widget. They can share it as code. I don't have to write them again. And if you think of large systems like an e-commerce website, you'll typically have a number of teams working on this system. So in an e-commerce example, we'll have probably some sort of a search team, we'll have some product catalog team, we'll have some basket management team, some checkout team, and so on. But we then need to have some scenarios that go through the whole system. So instead of having a separate testing team, that's responsibility is to write those scenarios again, they could just reuse the tasks that we've already created. So that's one way of scaling this thing up. It's just good old code reuse. It's not rocket science. I mean, we've been doing this in software development for ages. We can apply it to testing as well. Now, another benefit of introducing such abstraction is that, we could change the implementation of our goal. So perhaps instead of going through the UI, we could make our plan a journey task go through a REST API. So one of the problems with large-scale acceptance tests, especially on workflow-based systems like in insurance or transportation industries, is that those systems are typically workflow systems. So in order to verify a certain thing in a system, you have to go through all the steps of the workflow. And obviously, the longer the form is, the longer the tests are, etc. So one of the benefits here is that we could have some tasks that bring the system to a desired state using a faster delivery channel, like a REST API, and then perform the tests using the UI. So that's another way of speeding this stuff up. Of course, we'll need to have some sanity checks that test the whole flow, but it won't have to be all of them. And there's another interesting thing that we can do here. Well, perhaps instead of going through the external interface of the system, we could just talk directly to the application layer. So if you think about it, if you use something like the hexagon architecture or ports and adapters, your test could just become another adapter for your system. So instead of going through the external interface, we just send events direct to the system, and this makes it blazing fast, because we don't have to start up the server, deploy the application, wait for the page to load. We can just use code in memory. So the things I told you about are actually part of something a little bit larger. So over the last couple of years, my colleagues and myself, we've been working on something we called the Screenplay Pattern. So it's a way of structuring your automated acceptance tests that help them become a bit more scalable, a bit more maintainable. So let's walk through this process together. So as you already know, we start with an actor. This actor can be derived from a persona that our UX colleagues came up with. In order to interact with the system, we give the actor some abilities. Those abilities could be to browse the web using a web browser. They could be to interact with the REST API using some REST client, with the domain API, and so on. So basically what we give the actor is a client to a specific interface. So we decouple the connection to the interface from the actual task. Now, an actor can perform tasks. So the way this works is the actor has a simple method, attempts to, because now they'll try to perform a certain sequence of operations, and we can give them a list of tasks, such as now plan a journey. The actor can also verify the state of the system. So the verification is yet another task. They all follow the same interface, and I'll show you the details of this interface in a moment. Now, what is the task? So a task is basically an object that complies to the task interface, which basically means that a task will have a performance method that receives an actor. So each task will only have the performance, it receives the actor, and then inside the performance you call actor attempts to, and you pass it on. So you basically chain those tasks together. And it's just the whole exercise just becomes an exercise in list processing, really. Now we can have some static methods on the tasks to create a nice DSL, like choose origin of, but the main meat is in the performance method. Another important thing here is that each task in this particular implementation, and the implementation I'm showing you now is the Serenity JS implementation of this pattern. So this code is in TypeScript. Another important thing here is the toString method. So each task can be described using a human readable sentence. And I'll show you the reason for it in just a second. But first, let's focus on another thing. Instead of writing those tasks like this, instead of writing the whole classes, because this pattern is very, very common in code bases using Serenity JS, we can also have a shorthand notation for a task. And that's it. So this shorthand notation, where we use the task where factory method, we just create tasks with a specific description and a specific list of other tasks or interactions with the system. And this makes it very, very easy to quickly model those tasks that we have. So that's the Screenplay pattern as a whole. So as you know, we've got actors. Actors perform tasks. They also have abilities that enable those interactions with the system under test. They can ask questions about the system. And this all creates a nice and quite decoupled model of interacting with your application. What it also allows you to do is you could have interactions that interact with specific delivery channels. You can have interactions interacting with your application layer or domain layer. It's up to you. I mean, whatever task you create that has the performance method on it is just going to be executed. So what I think might help us bridge this domain gap, so get from the examples to the actual implementation, is something like the Screenplay pattern, is something like Serenity JS that implements it. And it also helps us to share the code easily. It helps us to model this stuff fairly quickly. And as we go along in the project, as we build those little libraries of interactions with our system, we can very easily start to reuse those, right? So we don't have to script the test every single time that we get a new feature. But now, let me tell you a bit more about this toString method that you saw in the task earlier. What was the purpose of that? So each test suite, each acceptance test suite has to work on different levels of communication. So at the very high level, like 10,000 feet level, we need to know the release readiness of the product. Is this thing going to work in production? Can we release it? Are all the features complete? Which features are incomplete? Which business capabilities are affected if the feature is not working? A bit lower, we've got capabilities and features. So which scenario affects which feature? Which particular step affects which scenario, and so on. And the reason why we could annotate those steps with those toString methods is so that we can create those reports automatically, so that we don't actually have to go through different tests for different interfaces, then analyze the results, compile them together, put them in some Excel spreadsheet. We can actually have it done automatically as we run the tests. So this works on the release readiness level, on the capabilities level, on the features level, and on the scenario level. And if you want, if you go through the web channel, I mean, each step can take a screenshot for you as well. So you get this living documentation of the system pretty much for free as you build it. Now, if you start doing this as you're actually developing a feature, then you get tests that are fast to run, that verify the domain logic. You actually help to ensure that the domain logic is implemented in one place rather than across the whole stack. And you can get those reports that you can present to the business even before there is any UI, which makes the whole cycle much, much faster. This also helps to build the understanding of how the feature works, how it's supposed to work. It helps to improve the communication between the developers and the testers, because now the testers see what stuff is actually tested, what features are verified. And if they want to come up with some edge cases, well, we can help them write those edge cases on the application level or the REST API level, rather than go through the UI every single time. So what I found works pretty well as an improvement to the process I showed you earlier is doing a couple of things. So instead of writing the acceptance tests in the format of, it should have unit tests, it should work, and so on, we can actually apply some BDD principles. We can come up with examples and rules to demonstrate how the user story is supposed to work. We can work on this together. So in the BDD, we've got this 3 amigos meeting. Well, 3 is basically any number between 3 and 7. And this meeting could involve the product owner, the developers, the testers, the UX guys, and so on, where we actually define those examples and the rules and how they should work in the system. Now, when we have those specifications, we can start automating them as we build the application. We don't have to go through the UI. We can go through the application layer. So again, if we're using something like hexagon or onion architecture, it just becomes yet another adapter to one of the ports that your application is exposing. We can start building this living documentation as we go, so we don't have it all left until the very last minute. And then this frees up the testers to actually do some more meaningful work. They can focus on exploratory testing, on usability testing, on performance testing, capacity testing, and so on, rather than just clicking buttons on a website. And what I found is that this sort of process results in fewer bugs and better software that's better aligned with what was needed in the first place. So yeah, so that's a little summary. So again, they don't have to exercise the UI. They don't have to exercise the application full stack. We don't have to have application deployed to run our acceptance tests. We can report consistently across the stack. And the nice thing about Serenity JS is that you can, if your application is in JavaScript, if it's a single-page application where your domain models are in JavaScript, then you can interact with those models using this framework. If your logic is in Java, then you can use Serenity BDD that John Ferguson Smart wrote, and you can use that. Now, those two libraries work together. So you can use them both on one project, and they just generate compatible reports. So you can use the right tool for the right part of your system. what I also found is that using using the BDD process helps us focus more on how a given story should work. What is the purpose of it? What is the business goal? What is trying to accomplish? And very often, just by having this conversation, we can get rid of quite a few features that have no value or purpose. And obviously, the best code to maintain is the one we never write. If there was no purpose, we can just get rid of it, right? And it's great to do it now before we start working on it. So if you'd like to play with the library, if you'd like to try this approach, I invite you to go to serenity.js.org. There's a tutorial. You can have a play around. And I would like to also show you how this works in practice, because now so far it's only been slides, right? And we developers actually prefer code, at least myself. Right, okay, let's see how that works. Cool. All right. So if the internet works, I should be able to run the scenario. So that's the scenario I was showing you earlier, where Connie tries to find the next train. So Serenity.js works as an extension of the Protractor framework, which allows you to, well, first of all, test all your Angular applications out of the box, but you can also test any other non-Angular application. So here we've got the Transport for London, which is non-Angular app, as you may know. Let's see how that works. The progress bar is spinning. So we can test any web app using the functionality that's currently provided outside of the box. We could test REST APIs as well. This would probably require us to come up with some custom abilities that we give to the actor. Now we can test the application layer. All right. So the internet works. Cool. And we've got a working test. Awesome. So this testing works in two phases, so that the test run produces intermediate JSON reports. So it doesn't create the HTML, nothing like that. It just creates the absolute minimum of what's needed to produce the test in the second pass. This allows you to do several things. So first of all, you can run those tests on different machines in your testing cluster, and then just aggregate the JSON and produce the report. You can run tests with using Serenity.js for the front end or the Node applications. You can use Serenity BDD to run the test for the backend, produce the JSON reports, aggregate them, produce the report. So this allows for some interesting workflows. As you can see, this particular run resulted a test execution report that tells me about the features. So I've got the journey planner. That tells me about the scenarios that were executed. So Connie looks for a train. That aggregates the information from the Cucumber files, so the user story details, that can show me all the steps that were performed, all the tasks. I can then go into those steps. I can see any associated screenshots, should I choose to have any. And this works for any interface of your system that you might have, because it's just the same pattern. Now, if I make the scenario fail, because now it's all good and nice when it's working, right? So let's break it a little bit. Another advantage of using those actors is that I can have several actors in one scenario. So for example, here I'm saying that now, given there are some trains leaving Canary Wharf at those particular times, I can have some administrator actor that goes to the system, sets up the test data for the following steps. So I can do it like that as well. Cool, the bus. And that got stuck. All right. So if we have a failing test, we'll see straight away which features are affected. We can then dive into a specific scenario. We can check out the specific step, and any assertion errors that are typically useful in this case will be shown in the report as well. So here I see that now the 1659 was not one of those I was expecting. So this is all nicely integrated together. And all this code you'll be able to find on the GitHub page of the project. So if you just go to GitHub and Serenity.js, look it up, or you can find it on the website, it will all be there for you to play with. Cool. Right, well, thanks so much for your time. Thanks for joining me here today. I hope I didn't bore you to death. And I hope this might be useful. If you have any questions, just come and find me.